When given a quadratic equation, here's just one example, and you've been going through the process of being able to factorize and solve that quadratic. And to cut a long story short, you go through the process, two numbers multiplied together to make 36, and add together to make minus 13. It's minus 9 and 4. So you're able to split up the minus 13x term and get to a point where your common factor for the first two terms is x, and the common factor for the second two terms is minus 2. And you have it factorized. And you can equal the factors to 0 to find out what the solutions for x are. And that should be well practiced. But what if we had it the other way around? What if we were told we had two roots to know what the quadratic was? So what would we do? Well, let's just say for sake of argument, I'm told my two roots are minus a half and 3, let's say for sake of argument. So we could just do the whole process in reverse and get to the point where we have two factors. And we could say, well, those two factors, when multiplied together, will equal 0. Open up the brackets, 2x times by x, 2x times by minus 3, 1 times by x, 1 times minus 3. And we have our quadratic that would indeed actually give us these roots here. And it was a reasonably painless process. You should be capable of following that sort of solving a quadratic in reverse and being able to get your quadratic from having been given two roots. However, there is a sort of a rule of thumb, a formula that you're allowed to know to allow you to get through that process more quickly. This equation that you see here is an equation that you should learn. It's not given you in a formula book. You should just know it. Something worthwhile putting in the back of your book. And it can be used. So what we have here is we have a structure of a quadratic equation, an x squared term, an x term, and a number on the end as a constant, and it's equal to 0. So you see here, if we were to take the two roots and add them together to get the sum and insert them there, and if we were to multiply the two roots together and put that product in here, we would be able to get our quadratic. So go back to that previous example where we had x was equal to minus a half and also equal to 3. We have a basic structure of x squared minus, now what is the sum of those two numbers? The sum of those two numbers is 5 over 2. And the product of those two numbers is minus 3 halves. So you can see there I've put in the sum of these two numbers and I put in the product of those two roots. Now it's not exactly in an ideal sort of format. We've got these fractions going on, so what we would normally do is we would multiply everything by 2, and when we multiply everything by 2, we would have our quadratic. And it's the same answer as the final line of my previous slide when I did it sort of a longer way, doing a reverse factorizing process. So just a way of us being able to get a quadratic from two given roots in a much faster speed. So what I want you to do is I want you to do a similar process with a range of questions. If you look on page 50 of your textbook, and in the exercise that we've been doing, which is exercise 3.4, and what I want you to look at is question 12. And I want you to work on, for the next, say, 15 minutes on a range of questions from question 12. Do a selection, including the more difficult ones, and you can finish those off for homework. In about 15 minutes' time, I'm going to ask you to watch one final video which shows you a use of this formula in a slightly different way than the example I've just given you.